Hi, my name is Harun Rashid. I am the lead chief investigator of ESCC Hub Project 2.5, Improving Australia's Climate Model Access. In this closeout video, I'll talk about the research that has been undertaken in this project, why we have done the research, and what are the main benefits of this research. So there are two deputy chief investigators in this project, Professor Christian Jakob from Monash University and Dr. Alan Prota from the Bureau of Meteorology. The climate challenges that we have addressed in this project are relevant to all ESCC Hub challenges, but in particular relevant to those projects which address climate variability and change, weather extremes, and coastal hazards. The research addressed in this project has to do with access model biases. Access is Australia's national weather and climate model. This is one of the best performing global climate models, as demonstrated through its participation in the couple model intercomparison project phase 5. Despite this good performance, however, Access show systematic biases in its simulation of important climate variables such as rainfall, and this kind of biases are common to all climate models in one form or another. Our project aims to reduce some of these biases by improving the model's representation of convection. So an example of the model biases is shown on the top right panel. The blue color shows the deficient rainfall over the maritime continent, and the red colors show excessive rainfall simulation by Access over the tropical Indian Ocean and the Southwest Pacific Ocean. The result of the project researchers' refinement of the convection scheme, model simulated rainfall has improved, and an example of that is shown in the bottom panel. What you can see here, where there was excessive rainfall over the tropical Indian Ocean, now there is a little bit less rainfall, and where there was deficient rainfall over the maritime continent, now there is a bit more increased rainfall. So this helped to reduce the model bias in the tropical region in the simulation of tropical rainfall. So to address this model bias problem, project researchers have conducted access experiments to understand the possible causes of tropical rainfall biases. They changed the model's horizontal resolution, made modifications to their existing convection scheme guided by their physical understanding of the system, and implemented a new convection scheme in separate experiments. Analysis of this of the simulation data from these experiments showed improvements in tropical rainfall and interseasonal variability simulations. The experiments and the resulting model improvements have been published in peer-reviewed journals and in Hub tech reports, and also presented at Hub's annual science symposium. One of the common model biases is an on-off behavior of rainfall at the time step level. This behavior is shown on the two top panels on the right there. After implementing a new convection scheme in the single column model version of Access, this on-off behavior was found to reduce, which is shown in the bottom panel on the right. So an important outcome of project research is an enhancement of Access weather and climate predictions. This will likely improve the quality of the Bureau of Meteorology's numerical weather prediction and seasonal predictions in the future. This model improvement has been acknowledged by the UK Met Office, and they have adopted some of the code changes in their model. The model is the base model of Access atmospheric model. This is also the base model of a number of weather prediction models from weather prediction centers around the world, like the Korean Meteorological Agency, India Meteorological Department, and the New Zealand Met Service. Project researchers have so the improved rainfall simulation will likely benefit all these partner organizations in their in improving their predictions, numerical weather prediction. Another important development is to come up with a new experimental experimental framework for single column model use. A process is now underway to use this framework in an international single column model intercomparison study. An important outcome also is the finding that the model's cloud rapid response and feedbacks are not sensitive to small changes in cloud parameters. Small cloud parameter changes are a standard process of model tuning, and it is good to know that the changes that are made during model tuning do not significantly affect the model's fundamental properties like climate sensitivity. The main benefits of the project are to help the next users in their research activity through delivery of an improved access model and model analysis tools. Examples of next users for access model are operational agencies like the Bureau of Meteorology and the UK Met Office, as well as other ESCC Hub projects and the Australian climate researchers who use access climate model in their research. An important benefit is to facilitate better policy development and decision-making outcomes by providing more reliable access predictions and projections. For example, water and disaster risk managers, land managers, and government authorities at various levels, businesses related to conventional and renewable energy and gas productions all need future climate change information for better informed planning of their respective future pathways. While access outputs may not be directly used by all these policymakers, they will be using climate products that likely use access and other model outputs. The main project achievements are to significantly advance our understanding of the causes of tropical rainfall biases in access climate model, improved simulations of tropical rainfall and interseasonal variability, adoption of some of our model improvements by the UK Met Office, development of a new experimental framework for single column models to study convection, which is expected to be used in an international model intercomparison study. The final improved version of access will enhance Australia's climate change science capability and contribute to future climate model intercomparison projects after CNIP 6. The next steps are to do with our new project under RPV5, Research Plan version 5. In this, under RPV5, we have project 5.1, in which we are going to use XSCM2 to evaluate its simulation and also to provide basis for its applications. XSCM2 will be used for ensemble simulations and ensemble of climate simulations, which will be useful for better estimating climate change signal by reducing the effect of internal climate variability. We will also use the atmospheric version, a relatively high resolution version of the access atmospheric model to conduct multi-decadal simulations. And the atmospheric model will incorporate some of the convection improvements that have been done under Project 2.5. An important objective of research under Project 5.1 is to facilitate applications of access, as I have just mentioned, by providing ensemble climate simulations, and also by providing atmospheric model data at relatively high resolution. The projects, other ESCC Hub projects that will benefit from this research are Project 5.2 on climate variability and change, 5.3 on regional climate change and projection, and 5.5 on weather hazards. So that's about it. Thank you very much for listening. If you have any question regarding the research that we have done, please contact me at the email address or phone number given on this page. Thank you.